I'm Sylvia from the Queensland Minerals and Energy Academy. Today, we're going to be talking about physics and how physics is used in the resources sector, in particular in engineering. To help us today, we're going to be talking to Tom Gargano, who's a civil engineer at Glencore's Mount Isa mines.
My name is Thomas Gargano and I am a graduate civil engineer working for Glencore out at George Fisher Mine. Studied a Bachelor of Civil Engineering with honours at Monash University, and I finished my studies in 2018. Throughout my studies, I was fortunate enough to be offered the opportunity to become a vacation student with Mount Isa Mines out at zinc processing. So down to the nitty-gritty of the day. Physics and engineering. So I guess, what is physics? Physics, I guess it's a fundamental science, which is pivotal and helps us to understand the world around us and how it works. Specifically, I guess it's a study of matter and energy and their relationships with one another. And yeah, by understanding this theory and the concepts of physics, it's pretty pivotal in understanding how the world works, and that's very widely used within engineering.
There are so many different fields of physics. Mechanics looks at objects moved by forces. Optics is the science of light. Electricity deals with the flow of electrical energy. Magnetism looks at objects which attract and repel. Acoustics is the study of sound waves. Thermodynamics looks at the transfer of heat between objects. Nuclear physics is the study of the nucleus of an atom, the protons, neutrons, and electrons. And quantum mechanics deals with subatomic particles.
So engineering, I guess, is a practical approach to science. Engineers effectively create viable solutions to technical problems.
Engineering is a practical approach to science and uses principles from various fields of science to design, build, create, invent, innovate, and problem solve. There are four main disciplines of engineering. Civil engineering deals with the design, construction, and maintenance of things like roads, bridges, dams, sewage systems, railways, and mines. There are many sub-disciplines of civil engineering, like structural, environmental, transport, and mining. Mechanical engineering looks at the design, manufacturing, and maintenance of mechanical systems, like engines and power plants. There are many sub-disciplines of mechanical engineering, like manufacturing, thermal, industrial, and acoustic. Electrical engineering focuses on the design and application of systems, including equipment and devices, which use electricity, electronics, and electromagnetism. There are many sub-disciplines of electrical engineering, like computing, electronic, optical, and power. Chemical engineering combines many areas of science as well as economics to produce, transport, and transform materials. There are many sub-disciplines of chemical engineering, like materials, chemical, and processing. The world around us is made possible with the knowledge and understanding of the physics principles and using them to our advantage.
Engineering is important in mining just as it is important within the whole world around us. I guess everything is made possible with engineering. There are many different hurdles and obstacles which create technical problems. Within the mining environment, we need to extract ore from up to 2 kilometers underground, and we need to then dig it out and then bring it to the surface. That's where mining engineers come in. They have the vast experience and knowledge to overcome these hurdles. We need to transport the ore. That's where civil engineers come in to design roads and create the transport systems to transport the ore. Then the grinding, flotation, and smelting processes, where we have mechanical and chemical engineers to pretty much streamline the process. Engineers from all fields are required from the day-to-day activities on the mine site. We have to overcome lots of the physical principles and understand them and pretty much problem solve.
What was your pathway to becoming an engineer? So what sort of subjects did you study, maybe at school and that type of thing?
Yep. So I guess probably early on in my high school days, I probably catered my education towards the maths and science fields, I guess. So yeah, maths, chemistry and physics were three of my major subjects that I studied up until year 12. I really enjoyed them, mainly because I probably excelled at them compared to some of my other subjects. So in excelling at these, they sort of steered me towards the science field.
What would be your favourite part of your job?
The wide variety of the different people we work with. I'm a civil engineer, but within our office, I'm working with mechanical engineers, I'm working with electrical engineers, working with construction officers, working with operators, working with human resources, working with management. There's such a wide variety of people to continue to learn off.
How would processes like that be used in your role or perhaps in the development of new technologies?
So engineering really it's an iterative process. The first design you complete will very rarely be the best design. So quite often we'll be given a concept, just say in terms of designing a building or a structure. We'll be given a concept, we'll put together a design, and then we will test it using computer software. And then we'll establish that maybe this isn't the best way to go about this. We need to add some more supports or some stronger members or use some different material, and we'll make modifications. And then we'll pretty much then repeat the process.
I think it's quite reassuring to hear from Tom, who's a professional in his field, that sometimes things don't go to plan. This is true for all fields of science. Sometimes it works, sometimes it doesn't. Sometimes we get the results we're expecting, and sometimes we don't. What science always gives us is something to learn. That's the beauty of it.
One of the teachers has asked, the students are going to be learning about contact and non-contact forces like friction and gravity, and how are forces like these taken into consideration in your role or in technologies in your role?
Forces such as gravity, as a civil engineer, a structural engineer, they are taken into account in every single design we complete. Gravity will affect the materials that we use, the size of the materials we use, the strength of our buildings that are required. Gravity is always considered in our buildings. In terms of contact forces, forces such as friction, mechanical engineers will always come across these contact forces in their conveyors. So mechanical engineers are commonly working with dynamic forces. So the conveyors that they build, they constantly have moving materials, moving parts. These will always be creating contact forces on them, and they're absolutely forces which mechanical engineers always need to be considering in their designs, just to make sure the conveyors or the buildings that they're putting in place, they're safe, pretty much. And yeah, we're always thinking about it, we're always considering it, and it's always in the back of our minds.
If you're using an explosive to, say, take down a wall, how do you determine or calculate where to put supports so that it doesn't collapse or that there's no other area affected that shouldn't be affected?
I guess in terms of an explosion, we would definitely try and consider it the same way we would any other forces, similar to wind or even earthquake or seismic forces. There would definitely be some assumptions involved as to where the explosion may be or the size of the explosion. But as we said before, the engineering process, it's an iterative process. So in terms of establishing where to put supports, initially we may just decide arbitrarily where to put supports. And then we might do that design, input this into the software, and then we'll test it. And then from there, we can establish if we need stronger supports or if we need more supports. And then we can go from there and we can increase the number of supports, and then we'll input it into the software and test it again.
When you went into engineering, So thinking sort of from school and then going into engineering, did you know how much you would be using software in your job?
I'm going to say probably not. I would say there's a lot more software that we use that I never imagined we'd be using, which again is really exciting. It keeps things so interesting, constantly learning new softwares to use and how to use them and the way we can incorporate them to make our jobs easier. And yeah, it's really exciting. It's lots of fun, and it makes our jobs a lot easier. And yeah, there's a plethora of different softwares that we can use, and yeah, I didn't really ever comprehend how much of it there really was.
What is one thing that you would like people to know about engineering or being an engineer?
One thing that's probably very important is the huge variety in the role. I'm not just, as an engineer, I'm not just sitting at a desk crunching numbers or working on software. Some days may be like that, but then the next day I might be out on site all day working with contractors, building what we've designed. One day we might be doing concept designs, just coming up with ideas, and then one day we might be detailing that design, and then one day then we'll be building it. The variety in our role changes on a day-to-day basis. No 2 days are the same. It just keeps things interesting, it keeps things exciting, and yeah, it's a really fun role to be involved in.
Thanks so much, Tom, for talking to us today about physics and engineering. As you can see, physics plays a huge role in the world around us and is critical to resource sector operations. Did you know that companies like Glencore's Mount Isa mines provide university students with the opportunity to undertake paid vacation work? This means students get to see firsthand how a mine site works and operates. For more information about the wide variety of careers available in the resources sector, visit the Awesome Resources Careers webpage.